Every time you ask a generative AI to draft an essay, summarize an article, or write code, you're not just moving bits in the cloud. You're waking up a physical infrastructure, data centers, power grids, cooling systems, chips, and cables spread across specific neighborhoods and countries. We like to talk about AI as if it were immaterial, a pure realm of intelligence. But intelligence at this scale is energy hungry. Training one large model has been estimated in some public cases to use hundreds of megawatt hours of electricity, comparable to the annual use of dozens of US homes. And once a model is deployed, the ongoing use can dominate. Billions of prompts a day, each small computation that adds up to a significant continuous load. Recent research comparing task-specific and general-purpose AI systems finds that large, multi-purpose generative models can use 1 to 2 orders of magnitude more energy than smaller, single-task models doing similar work. In plain language, that means answering the same numbers of queries with a big general model can consume 10 to 100 times more energy than with a linear, specialized system. This episode is about 3 layers of impact: energy, ecology, and politics. Energy first. As universities, companies, and governments integrate AI into search productivity tools and learning platforms, they push more and more routine actions onto servers. What used to be a simple local operation, typing in a document editor, searching an offline library, now becomes a call to a model sitting in a distant data center. Each of those calls consumes electricity, and multiply across millions of users, the curve climbs quickly. Ecology second. Data centers are built on land that has other possible uses. They often need large volumes of water for cooling. Some public reporting has suggested that a single large AI data center can use millions of liters of water a day, depending on climate and design, of course. In regions already facing drought or agricultural stress, that extra draw can become politically sensitive very quickly. The hardware depends on global mining and manufacturing chains for materials like copper, rare earths, and semiconductors, tying, for example, your AI-assisted homework sessions to extractive industries in other parts of the world. Politics and society third. These infrastructures do not appear in a vacuum. They're negotiated. Local governments may offer tax breaks, cheap power, or looser regulations to attract AI and cloud facilities, hoping for jobs and prestige. Communities living near those facilities may experience higher energy prices, environmental stress, or increased surveillance capacities, with limited say in the deals. Now connect this to AI in education and work. A university announces a bold initiative to bring AI to every classroom, promising personalized learning, new forms of assessment, and cutting-edge research. A company rolls out AI copilots to every employee to boost productivity and innovation. On the surface, these moves are framed as purely cognitive. Better essays, better feedback, better analysis. But beneath that surface, they lock institutions into particular vendors, data flows, and energy infrastructures. AI becomes an atmosphere that feels weightless, even as it pulls more resources from the ground and more power into a small number of firms and states. There is also a global justice dimension. The United States, the European Union, and China are racing to secure chips, energy sources, and regulatory influence over AI. Many countries in the global south risk becoming primarily suppliers of data, minerals, or hosting locations, while having less leverage over the rules that govern AI deployment. So we face a paradox. AI can help us design better climate models, optimize logistics, and manage power grids more intelligently. At the same time, the expansion of AI infrastructures can increase overall energy demand, intensify extraction, and concentrate political and economic power. For students and early career professionals, this is not an abstract debate. Using AI tools is a choice about your own cognitive labor, but it's also a tiny participation in these larger systems. Universities and employers that proudly commit to sustainability and climate goals may, at the same time, sign contracts that quietly raise the digital and energy footprints. An agnostic approach does not mean ignoring these tensions. It means asking, case by case, when does AI provide enough educational, social, or climate benefits to justify its energy and ecological cost? Where do those costs fall, and who gets a voice in deciding whether they are acceptable? And in the end, the question is not simply, should I use AI for this assignment, or will AI take my job? It is also, whose grid, whose water, whose land, and whose political choices are quietly supporting this apparently weightless intelligence? And how do I feel about that trade-off?